Welcome, and in this video we're going to start another series on other functions and look at variation with physical applications as well. So this time around we have two different learning targets. We want to be able to talk about common functions algebraically and graphically. That's kind of one piece, and then variation is hugely popular in physical applications, so we want to look at how changing one quantity affects another quantity. And so there's some mathematics that we can look at with that. And so there's other things here in the learning steps that are detailed to help us reach that. But let's dive in with that other common functions piece. We've studied linear and quadratic functions, right? But there are more, and I'm sure from your previous experiences with math, there's likely other functions that you've encountered, right? For example, a cubic or something like that. So what we're going to do is do a little bit of exploration, and so we're going to focus on the case where n is a natural number. Okay, and we want to look at these types of functions below. And so here they are. Okay, there's the ax to the n, a over x to the n, and then like the radical functions, and then the absolute value functions. And for each of these, we want to look at this in decimals, okay? And we'll use sliders for a and n, and then describe the shape. Think about the shape when it is even and odd, for instance, and talk about intercepts, and then kind of look at how the function behaves for very large positive and negative values of x. Okay, so let's go ahead and do that. I'll back out here, and I have decimals open, and I have the different functions plotted here. And so the first one is that polynomial class, so a x to the n. We call those all polynomials, or actually these are power functions. They're a subset of the polynomials, but I digress. So if we increase a, what happens? Well, a is just going to make it increase or decrease quicker. That's really all a does. Okay, so a is a scaling. Makes you go up faster or down slower. And n, what happens here, and here I don't think I can set this to be an integer, so we kind of have to play around a little bit carefully. But if I do n is 2, we get our parabola, which we saw, so that's x squared. If we do n is 3, we get this nice s, or this snake shape, and this is the graph of the cubic function. Okay, so we have intercept at 0, 0, and then one side, it's always increasing, actually. It's an always increasing function, and so as we go off to the right, x gets, y gets much larger, and as we go to the left, y actually is becoming a smaller negative number. Okay, and then again, playing around here, 4, we get right there. 4, we get kind of a flattened parabola. Okay, this is a graph of a quartic polynomial. And so then, okay, we have 5. 5 should look, there we go. It looks like a flattened cubic. And really, that's kind of the pattern that you see is we have our linear, quadratic, and cubic functions. And then after that, they all kind of flatten out. Okay, so that one's, we're kind of done with that one. Okay, let's look at this one, and I'll reset this to 1. So now we're looking at kind of reciprocal functions. Okay, and don't say inverse, it's reciprocal. Okay, so this would just be 1 over x. Okay, hugely popular function that we need to know, and we will see many more times this semester. So here we are. We have, and this one is actually decreasing on its entire domain, but so it's undefined at 0, but otherwise we have it decreasing as we go to the right to 0, and then here this would also be decreasing as we go to the right, but as we go off to minus infinity, it actually approaches 0 as well. Okay, and really all that happens, a is going to be that scaling, so not a big deal, but when we go to 2, we notice that that part that was down here kind of flips up top, okay? And that happens because we're squaring it, right? And then the third, these ones don't get to be too interesting. It just looks a little bit more flat, etc. Okay? If we look at the radical functions, okay? If we look at just n is equal to 1, we get our basic square root, or our line, sorry. But then when we change to 2, we get a square root because that'd be 1/2 in the exponent, so it'd be x to the 1/2 square root of x. So this is the graph of the square root function. Okay, absolutely need to know this one as well. Okay, and then again you can continue to play. 3, we get the graph of the cube root. So similar, but then because you allow odd number or negative numbers underneath the radical, that's why we have this piece. Okay, you can have negatives under an odd radical. Okay, and last thing, square root or absolute value. So this one is a v. You can have a sharp point. Really, it's a line. But then because it's absolute value, we reflect it over the x-axis. So that's what we get. Okay, and I just want to go back in here for a second here. And so we went through and explored all these different functions. You do need to know some functions. And here is the list that you need to know. Oops, let's go back. So you need to know f of x equals x, or ax. That's your lines. You need to know f of x is equal to ax squared. That's your quadratics. F of x equals ax cubed. That's your cubic graphs. And then f of x is equal to 1 over x. Most certainly that's your reciprocal function. And then we want to know the squared reciprocal function as well. Okay. Then you need to know your square root function. Okay. It doesn't hurt, this one I'm going to make optional, but knowing the cube root function. And then you also need to know the absolute value function. Okay. So that list, absolutely need to know what they look like and be able to work with them. All right. So that's going to conclude this video, and then in the next video we'll look at another type or another class of functions.